Hi everyone, welcome to the project showcase on this beautiful Sunday afternoon. I'm Christina, the president of Project Night. I'm actually wearing a Project Night t-shirt if you can see it. And remember to answer that survey if you want a free t-shirt. And the Project Ignite Showcase is the big finale of Project Night, and we are really excited to see all of you join us today. And before we get to see our fantastic project for the spring 2021, I would like to say a few words as introduction. So Project Ignite have been around for 6 years since 2015. In past years, we've offered in-person workshops and worked on over 40 projects in various STEAM disciplines with more than 250 high school students from more than 20 high schools in the greater Pittsburgh area. This year is the first time ever we use a completely remote format which have imposed constraint on our interaction and project topics. But all of the students, project advisors, and executive board worked hard to innovate, collaborate, and overcome the challenges. Due to the time limit, I can't introduce every one of us. But yeah, I would like to thank you all for making this happen. Also, we will appreciate it if you can fill out our final feedback survey to help us further improve for the next year. And Michelle should be putting the link in the chat now. So today we're going to present our 7 exciting projects and virtually celebrate our hard work this semester. Each team will present their final project in 10 to 20 minutes, and we will have about 5 minutes to open up to the audience for a Q&A session. If you want to ask any question or just want to praise or comment on the team's hard work, you can do so in chat, or you can raise your virtual hand so I can coordinate to invite you to unmute and speak up. Any questions so far? Okay. If not, I'm now going to give the floor to our first team, the cookie team.
All right, let me share my screen. Can everybody see my screen okay?
Yep.
Okay, hey everyone. My name is Jackie. I'm with the Cookie Recipe Optimization Group. I'm one of the mentors, and I'm a third-year PhD student at CMU's Robotics Institute.
I'm Nina. I'm also one of the mentors, and I'm an undergrad.
Hi, my name is Asta, and I'm a student that worked on this project.
Hi, my name is Gayatri, and I'm also a student that worked on this project.
Hi, my name is Emery, and I'm also one of the students.
All right, I think Jupiter connected, but it's not on. Oh, there you go.
Yeah, here I am. Okay, so the goal of our project was to find the best cookie recipe through optimizing a variety of recipes. And through this, we learned the basics of optimization and applied it to our and we can apply it to future experiments. So first was research, and we researched like what cookie to make, and then what recipe we were going to use, and how to use and like how to optimize it, and how to bake. And then we went on to optimization, so implementing what we researched and using coding an algorithm and putting it into sheets. And then we started experimenting baking cookies and getting closer to the final recipe. And once we hit like what we thought, once we ran out of time and we went on to like what we thought was the best of what we made, that was the final recipe, and that's what we're using. And then when we went on to brainstorming, so throughout the whole project, we brainstormed things, whenever someone had an idea, they would tell everyone about it, and then everyone would discuss it, just think about like how it would change the project and how it would help. And then if we decided we liked it, we would implement it. So the few big things we discussed and brainstormed was first, like what cookie we were gonna make, like whether it would be sugar, chocolate chip, all those different types of cookies. And we decided on chocolate chip because we thought it would be like it's the typical cookie. And then we went through like what different recipes to use, like based on how like how simple the recipe was and how easy how well we could make it, and to make sure we didn't mess it up or have any errors. And after deciding the cookie recipe, we moved on to like how to rate each cookie and like what categories of rating we would do, like, and how to weight each category, so how important each category was to the overall cookie. And then we decided how to bake the cookies and like what process we were going to use to bake it, and like how we were going to compare results. And then we discussed and brainstormed what new ingredients we were going to add at the end of it. Like once we finished all the we like optimized the main recipe and we got it to like what we thought was a good point, we discussed what new ingredients would be good to add and how they would help, and then we went through that.
So optimization is a rather complex, idea, but I'm going to try my best to explain this in simple terms. So we started off with the base chocolate chip cookie. We used the one from Tasty because we all agreed on that one and they have great recipes. And we decided that there were 13 different variables in that experiment. Some include, cocoa powder, amount of sugar, baking time. Emery will get into that a little bit later. So the sample test recipes that we had, the one chocolate chip recipe that we had, we basically wanted to move that to the most optimum level. And that's what the graph shows. So the black dot at the very top is our base recipe. And with every intersection on that graph is basically a new experiment, a new baking set. And we're trying to get to eventually the arrow at the bottom, which would be considered the most optimum recipe, or when all the variables in the recipe are at 0. So we inputted our base recipe into a Python algorithm, changed around the deltas a little bit, and when we got our output, we got a new base recipe, and we baked that. We rated it on a scale of -3 to 3. Negative meaning that something was missing something, it had too little of something, and positive meaning that it had too much of something. The perfect was 0. So we rated each of the 13 variables on a scale of -3 to 3. And again, we inputted that base recipe into a Python algorithm to basically, like it says, move the base recipe in the direction of the most optimum recipe. And we kept repeating this process until all of our ratings were at 0. There's a couple problems with this that Asta will get into a little bit later, errors in how we could optimize. But initially, when you get that rating set to be 0, you reach the most optimum chocolate chip cookie.
All right, so we split this project into 2 phases. And the first phase is topic exploration. And that's what Japnur and Gayatri talked about. It was brainstorming and learning how optimization works, finalizing the project details, finalizing what base recipe we were going to use. We ended up using a recipe from BuzzFeed's Tasty. We baked that recipe and evaluated it. And then from there, we created an objective rating scale and categories on a Google Sheets document. And so after having our optimization formula ready, and having our recipe ready, we started to bake. And we baked it, we rated it, we altered it with the algorithm, and then we repeated that until we got a recipe that we all thought was great. And so after we have our final base recipe, we experimented with add-ins like cinnamon or different types of nuts or espresso powder. And after baking cookies with those add-ins and rating them, we then finalized our final recipe with the base recipe and all the add-ins we liked.
So these are some of the pictures of just some of the cookies we baked over our project. Everyone in our group, even our advisors, took place in baking around a dozen cookies per week. What are our variables? The variables are the items that we are changing and optimizing for. We had the 13 variables of baking time, oven temperature, mass of each cookie, percent cocoa, and all of the ingredients in our most basic chocolate chip cookie recipe, which are listed on the screen. For each of these variables, we then set ranges. Ranges are the minimum and maximum amount for each variable. This ensures that we did not have an extreme or too little amount of one ingredient and kept our recipe in the correct proportions. We also set relationships between some of the variables, which are correlations. One prime example is that we made temperature and baking time inversely correlated, which means when the oven temperature increases, the baking time goes down and vice versa. This ensures that we did not generate recipes that would create extremely burnt cookies. And one other example is that we related the amount of brown sugar and white sugar. As covered earlier, we then came up with a rating scale from -3 to +3. The negative numbers mean that there is not enough of an item, and the positive numbers mean too much. The things that we found most important in cookies and rated were the sweetness, crispiness, uniformity, chocolate flavor, greasiness, flavor complexity, overall flavor, recipe complexity, and overall texture. The last two groups of overall texture and flavor were only implemented in the recipe testing of additional ingredients, which was mentioned earlier by Asta. We used this rating scale to determine a loss number after baking each batch of cookies, and it told us how good or bad the recipe was overall. And our goal was to get close to 0, but even though we did not achieve a perfect 0, we got loss numbers that were only a few tenths off. Some challenges we faced in our project were mostly with the virtual format. With that, the main one was standardization. Before we started our experimentation, our group had to make sure we had efficient and consistent recipe process across all of our bakes. To do so, we decided to measure ingredients in grams with kitchen scales instead of by cups to achieve the least amount of error. And we also had to write out a standardized recipe process that accounted for all the kitchen tools we had available to us in our different houses. Trying to find the best cookie also came along with a lot of tasting and rating, but this also provided some challenges because we did not have the ability to taste each other's cookies, and different ovens can provide some very different results while baking the same recipe. Finally, with our experimentation with additional ingredients, we did have some challenges with browning the butter and an unexpected loss of a lot of moisture in our cookie dough, but we were able to adjust accordingly.
All right, so here is our final chocolate chip cookie recipe. Take a screenshot, take a picture, write it down, whatever, because this is the real stuff. And so in this recipe, what we do is we first brown butter. And what browning butter is heating butter on the stove until the milk solids are nice and toasty and all the water has evaporated. And what this does is it gives the butter a really nice nutty flavor, which goes great in the cookie. So you take the brown butter, you mix in the salt and the sugar and create a paste. And to that paste, you add the vanilla and the egg and then mix it until it's light and runny. Then you sift in the flour and the baking soda and mix until there are no traces of any dry ingredients visible, but not more than that. Do not overmix. Then after that, you fold in the chocolate chips and then chill the dough for around 30 minutes. What this does is it hydrates the dough and it allows the flavors to deepen. And then you portion the cookies out into 12 parts and break them at 355 degrees Fahrenheit for approximately 16 minutes. And so this is our base recipe, but on the next slide, we experimented with a few add-ins and created a cookie recipe that tasted the best. So in this recipe, it's the exact same, except that with the dry ingredients, we have added 1.5 teaspoons of cinnamon, and instead of 280 grams of chocolate chips, we have 220 grams of chocolate chips and 60 grams of walnuts. All right, and so the main differences between the original BuzzFeed recipe and our recipe is that our recipe used more butter, more baking soda, less sugar, salt, and flour, the same amount of eggs and vanilla, because you can't really split an egg, and we added walnuts and cinnamon to our final recipe. And so this resulted in a more robust and flavorful cookie. Those ingredient differences combined with our browning of the butter made for a much, much better cookie overall.
So optimization has a lot of room for improvement, and it can be applied to many different fields. In the spectrum of food, you can experiment with other ingredients and other types of cookies as well. We did chocolate chip because that's the most common base recipe, but you can also do sugar, snickerdoodle, oatmeal raisin, white chocolate academia, or any other cookies that you might want to try. Within the food related spectrum, you can also try with different recipes like pasta recipes, for example. Just try and play around with different variables and adjust the deltas accordingly to get to your most optimum recipe while rating on the -3 to 3 scale. And you can also apply optimization to non-food related items. You can optimize diets, sports related skills, driving routes, as long as you have a base starting point and a direction in which you want to reach. For example, like the driving routes, the minimum amount of time you want to get to a certain place, you can pretty much optimize anything.
Yeah, I think that's all for the presentation. We're open.
Thank you. This is a really, really great presentation. I really hope like Zoom have a virtual functionality of like playing a virtual round of applause or something. But yeah, I think clapping on my side. So congrats. Any question from the crowd?
The 13 variables you guys considered, was that just like an arbitrary number, or was that like what you guys determined to be the most important factors that controlled what made it, like what affected the final product? Like, could you have done more? Could you have done less?
We based it off of the ingredients that were in the original recipe and things that we thought were important. So like we thought that the mass of the cookie, of each cookie ball, it would have a big effect on the final product. Same with oven temperature and baking time. So that was where we based it off of.
So if someone had like a different preference for what cookies they would like, would you guys be able to like change the program to account for that? It's like, can it basically like adjust based on what each user's preference is? Like, if so, example, if I were to given like a scale of 1 to 10, how much I want my cookie to be crispy or uniform or have this flavor, then would it be able to give me like a recipe for that? See if I really like, I'm not a big fan of sweetness, but I really like crispy cookies. If I were that, would it be able to account for that?
So we have the rating scale, and then what if in your case, what you would do is you would do it individually, and then you'd like go through multiple optimizations. So like you would have the base one, which is like what we did, and then you would bake it and taste it and then rate it based on those, and then put it into the algorithm, and then you get the new numbers and keep doing that. And then as the loss goes down, you can get to your favorite cookie and it'll be personalized to you.
Okay, that's actually really cool how that works. Yeah, thank you. And I'm definitely trying the recipe at the end too. I have several screenshots just in case something fails. Got several backups ready to go.
Yep, cool. Victor, I see your hand.
Does your recipe taste better than the BuzzFeed one?
Well, obviously, taste is subjective, but yes, I think as a group we have agreed that our cookie is a lot more flavorful. The texture is just better than the BuzzFeed one. So I would say yes, it does taste better.
Sure, taste is subjective, but ours is objectively better. I mean, you can't.
Okay.
I think the loss for the BuzzFeed one was over 2, and then the loss for ours got less than 1. So
Right. Our subjective opinions made for an objectively better cookie.
This is Project 9 approved objective rating. Cool. Any other question or comment? Oh, I see your hand.
Hi, this is Dipmoor's mom here. I actually have a quick question. I was just wondering which cookie came in. So the cinnamon and the walnut was the final one, but was there a second, like, what's the next one on the scale other than that? So you spoke about the base cookie and the final being the cinnamon and walnut one. So what was the runner-up cookie next to the final chocolate chip with the walnut and the cinnamon add-ins?
In our project with the add-ins, we took the overall loss for each ingredient that we tested in them, and the best type of nut that we used was the walnut. And then for the add-in of either coffee or cinnamon, the cinnamon beat the coffee, and then so the coffee was second best. So I'd say probably walnuts and coffee was the second best.
Thank you.
I have a question.
Go ahead, Will.
Yeah. Do you have a version of your optimization algorithm available if someone wants to run this experiment themselves, so that we can, or one that we could store as part of Project Ignite to show to other people later on when we're all gone on to college or whatever?
Like, if you want to make a copy of our Google Sheets document, go for it, I guess, because that's where
Okay.
everything is.
So yeah, it's all in the Google Sheets.
Yeah.
Cool. Well, that'll be stored in the Project Ignite Google Drive as long as you're all okay with that, so we can in the future show off your excellent cookie making skills.
Yeah, and we can probably do this optimization for each round. And if we can do like go back to in-person mode again, we just made tons of cookie to feed our students, and we will probably have different optimization for different classes of students. Yeah. Cool. So if there's no any other question, we can move on to our next team, the environmental technology team.
I'm going to share my screen. Can everyone see that?
Yep.
Okay, we were the Project Ignite Environmental Tech Group, and our group members were Carmen, Emma, Nicole, Sonica, Lauren, and me. And then our leaders or advisors were Mahima, Sydney, and Steven.
So for our project, we kind of had two goals. Our first goal was to develop a sensor that can be used for different plants, and we would use that to test like the temperature, water, pH, and like other parameters. And our second goal was to design a website that we can link the sensor to so that whoever uses the sensor can identify like the health of their plant and how to adjust their plant treatment.
So this is our mission, and the Sensors Project's mission was to create an easier way for people to keep plants alive and healthy, because it can be difficult to understand why a plant is not living to its full potential, but with our sensor, the process is easy and simplified.
So basically, the problem that we're trying to solve is making it easier for people to maintain their houseplants and encourage growing houseplants, because altogether, growing your own houseplants and having a garden will help fight climate change, like these small actions. Okay, so this is our MVP slide, our minimal viable project. So our original project just included the idea. We just wanted to develop a sensor to be able to test different growing conditions of plants. We just wanted a way for people who didn't really know or didn't have much experience with growing plants were able to see the different factors and how they needed to adjust them in like a digital way. So we wanted to monitor factors like temperature, pH, and water level. And so far, as our group has like done our research and worked on our sensors, they have been able to collect this data successfully. And then additionally, we were able to create a website, which adds to our product because you're able to see it in more of like a virtual way on a website. Okay, and then here is just a quick slide of our group's different plants. As you can see, we have a large variety. We have everything from like just like the common house plant to like some interesting cactuses and succulents. And then we also have a few of the plants, different people got the same plants, like the bromeliad, I think, which is the one with like the red flower in the middle. A couple group members had. We just wanted to see like how it would vary for different group members, and just we wanted to sort of test all types of plants.
This is just our weekly plan on what we were going to work on, and this really helped us stay on track. And we shared this on the midway meeting, and the last 5 weeks since, we've kept pretty well to our schedule, because basically it was just we had to split up into a website and sensor team, and that's all we did. And up to last week we just did a couple final touches. And then these are sensors that we ended up using. On the picture on the left, you can see those little white bits, that's what actually goes into the soil, and it's connected to our Raspberry Pi. And on the right picture, you can see that it's actually in the soil there, and that's how it'll measure the pH, temperature, the water and sunlight of the your specific plant. And then here we have a video of the sensor being used in action. It's just a little demo. Okay, as you can see here in the very beginning, it showed just a little bit of code, and it basically just said, oh, your plant needs some water. And then afterwards, after you put the water in, it'll notify you your plant is healthy. So if we made this a little more user-friendly, we would have a display that just said, your plant needs more water, your plant is healthy, your plant needs this, your plant needs that, which makes it really simplified. And here you can see we just made a small code in Python that is connected to the Raspberry Pi for all the sensors. And then this is just a little bit of the code from the GitHub that connected the data from the sensors to our website.
So this is our website that has a little bit of information about our sensor. On the landing page, we have a little bit about what the sensor is, again, our mission, who worked on this with the team, and also a cool feature here at the bottom, which Sonika will explain.
Yeah, so basically this is just an implemented Google form to fill out with any questions or concerns regarding the plant sensor. And I think Mahima's showing how it works right now.
Yep, so there's the input I just put in, but yeah.
So this is our plant search bar. Currently, our plant database is only limited to the plants that we had bought originally. So we added a Google search bar that links like the website to Google. So if you have a plant that you're trying to look up, you can just use that instead.
This is our plant database page. It's very minimal for now, as it just has the 8 plants that our group had bought. But we would hope in the future, and with more time, we would be able to expand that list so that even if you didn't have access to our sensors, that you could just easily Google and find all the information put in one place, because there's oftentimes just little facts you may not know on how to take care of your plant.
Okay, and then lastly, we have the My Plant tab and page. So this is sort of like the opposite of our minimum viable project. This is sort of something we'd like to continue and extend our project into in the future. Our idea for this page was to have somewhere where you could see your own data and the measurements from the sensors of your own plants. And we wanted to make it in a way so that it would connect and you would be able to have this interface that you could log into and see your own plants on the website.
This is just the GitHub for all our code. We're not going to go through it, but.
Okay, so next up is some of the challenges we faced. So like most groups, it was one of the biggest things we faced this year was being virtual. In the beginning, we had some issues like trying to work out how are we going to make a physical project when we can't share like resources and we're all separate. But that's sort of why we wanted to use the website. And so that we were able to all like collaborate on the project together, and that allowed us, a lot of our group members didn't have any experience in code, but our leaders taught us, and some other people in the group who knew code were able to teach us, and we got some experience in HTML and building websites. And then the hardware for the physical sensor, I mentioned that. And 10 meetings due to time constraints. It was hard just getting everyone to meet together, but we made it work. It was, I think most groups dealt with that. And communication was a little difficult, but we were able to collaborate and buy plants together. Everyone was able to go to the store and we like worked out how to buy our own plants, and it ended up working out really well.
Finally, for the future, our goals are to connect the sensor to the website through the My Plant page, and also adding and finishing off the sensors by including some like pH and sunlight monitors. And just to conclude it off, it would be testing with the sensors on a larger variety of plants.
Does anyone have any questions?
Cool. Very glad to see this presentation. You've made so much progress since last time. I see Will, you raise your hand.
If no one else has questions, I will absolutely start. So are you going to continue this project? Are you planning on actually implementing the My Plant thing, or is this sort of like a done what you could do and then now you're going to move on with your lives?
I mean,
oh, sorry.
It's unlikely we will, but we did buy a couple extra parts because some of our group members were interested in kind of finishing it and having one of their own. So, you know, it's a possibility.
Yeah. I could actually genuinely see this becoming a like, there have got to be products like this on the market somewhere, I would imagine. And if not, then that's an open space for, I mean, because keeping your houseplants alive is notoriously difficult, especially for things like orchids. So it's a very cool project. Also, please feel free to submit reimbursements for your houseplants. I haven't seen those yet, so if you wanted to, Project Ignite will buy them for you.
Yeah, we have way more budget to spend, but no. Cool. I see another hand in the participant.
Does the sensor only work for houseplants, or could it work for like outdoor plants and other plants?
I think it could work for any plant as long as you know like the optimal ranges for like temperature and pH and water, because as long as you can just like stick it in the soil, you can get the information from it.
Okay, cool.
Subham, I see your hand.
You can just call me Sub. If you were to like sell this product, I saw that in the picture there were like a lot of sensors they had to attach. I'm assuming that not everybody knows how to like how to actually implement the sensors, how to get them hooked up to the code and whatnot, how to run the script. So will you guys like would you guys include like almost like an instructional manual to basically explain like here's what this does, here's how you hook it up?
Yeah, well, with any new product, you would probably include an instruction manual. But additionally, we would have planned to have our plant database be a lot larger, and the code would already have the information in it necessary. And then all you would have to do is stick the sensor into your soil, and that would be the end of it. So it'd be a pretty simple process.
would people be able to push like data into that database? Like, for example, like in the like, would you like have a Google form similar to the one that you showed, but instead of just questions, it was, entering a plant name, entering the optimal ranges, and then you could go through and just approve them, make sure that they're actually correct information, or will you just try to keep it all contained within the group?
That would be a very feasible idea, especially because it's pretty easy just to add one extra, section of code for a specific plant, as long as you're given the information. And that's the reason why we have the website and the Google form, so that we can get feedback better.
Thank you. That answers my questions.
Cool. Any other questions from the audience or comments?
I just think it's cool. Really don't know what else to say.
Yeah, every project is cool, and yeah.
Thank you.
Okay, now we can move on to our next team, the politics in the information age.
Hey everyone, I'm Shuban. I'm here with Danuk. Alina wasn't able to make it. And here with the Summarize project. Our mentors were Jasmine, Snigdha, and Tyler. So just a quick shout out to them.
All right, so for a project, we want to like find a way in order to educate and inform like others in our communities about pressing issues and topics. And we figured that by doing this, we can create a better, more inclusive community.
So how we made this topic interesting for anyone who isn't interested in politics or like current events. Current events will affect students and adults regardless of whether or not they're involved in them. In addition, the news caters to all interests, ranging from politics to science. The only issue of current day news is that some information may be misconstrued or falsely told. Our project weeds out these fake news articles through extensive research and attempts to share unbiased news. So what we do is we obviously look at other news articles. We try to take out the parts that are biased. We try to construct our own type of argument, but obviously that argument is going to be unbiased so that our high school students can learn in a quick and unbiased manner.
So in order to like solve this problem, we decided to split up into two teams, the content team and the development team. The content team focused on like making articles and like providing information, as Shubin talked about earlier, in like a easy to understand way without any bias. And the development team worked on like building the website for like others to actually view these articles.
So what is the problem in the status quo and what are we trying to solve? Why should you all care about this? Middle and high schoolers are super busy with school and extracurriculars, and they don't website every morning to get caught up in current events. However, it's really important for kids to get in politics and what's going on in the world starting at a young age. Political literacy and global mindedness are skills that every kid should ideally have. For creating this Summarize project is because all of the most popular news sources are pretty biased. So we wanted to create a platform where kids can learn about pressing current issues in a nonpartisan manner so that they have the ability to form opinions for themselves. Now, specifically, this idea of forming opinions is really important for us here at like the Project Ignite group, mainly because a majority of news sources will skew their news towards like one sort of like political side, whether it be like CNN, who slightly like leans towards like a Democratic side, or like Fox News, like obviously like the two classic news sources. So what we try to do is, okay, we don't want to take into account these things, or like we don't want to take into account political biases, because obviously we are high school students. We want to be informative about politics itself. We also don't want to be skewed when we're understanding and learning about the world. Specifically at a young age, we don't want biases that are like already forming in our heads, because if they do form in our heads, they're going to be like reinforced as we age and as we grow older. As a result, we'll like grow up to be like very biased adults, maybe not like people who want to like learn about. We are like kind of fighting this problem at its root, and saying, hey, we don't want you guys to be biased. We want you to learn the most about the world that you can. that is the best way to do that, or at least one of the ways you can do that.
So, like during the brainstorming process, so first we decided to like make a project where students could like share their ideas and view other ideas similar to Reddit. And so we wanted to like design an algorithm to find unbiased news articles, which the content like, well, we didn't exactly make an algorithm, but the content team looked to find articles with unbiased perspectives in order to sort of mimic that in their own articles. And then we also looked at different types of websites in order to like model our own website using HTML.
So a few challenges we faced as we worked on the project. One of the biggest challenges we did face was choosing an idea. We spent about 1 to 2 Ignite calls just discussing the best way to reach out to students. We had discussions about, hey, do we want to use Reddit or like a sort of Reddit forum, as Danuk was talking about before, or maybe just hold pure discussions and like focus on that. But obviously we wanted to integrate coding and like programming as a way to reach out to our students. So we decided to reach to that website. And I think the idea that an idea on how to like communicate our ideas was the hardest challenge that we faced. But obviously, quick road bump, and then the rest of it was smooth sailing.
Right. So our minimal viable product is our website, because that was like the primary thing that we were working on in order to like show other people in our community different articles with unbiased perspectives.
So how does the MVP solve our problem? Through extensive research and nonpartisan reporting, the original issue of fake news based, and since high schoolers write the articles, other high schoolers may be incentivized to route these events. Since our articles are short and sweet format, they're easily accessible, making the website more views. So 2 ways we solve the problem. 1, we get rid of fake news, and 2, we make our platform high school based. We make the articles very quick and easy to read. So we solve both of these issues at hand.
So in the future for a project, we plan on just holding like workshops for students to be able to like have in-depth discussions and like share their various opinions and perspectives, so that other students can also be able to learn more about the topic and have more and be more open-minded. And here's our website. So here's like the homepage, and here we just like give an introduction to like what we're trying to do and who we are. And then our blog is where we have the articles. So like currently we have 3 articles. So some on like controversial topics such as Dr. Seuss, and some on like pressing topics such as like flooding and COVID-19. So if you click on like the button, then it takes you to the article itself. And here is the article that our content team has developed. And here like it shows both like the introduction to like the actual topic, as well as the 2 sides that like if it's like a debate, it shows the 2 sides that are like it presents both sides of the argument. And then for the other pressing issues, we just share just general information and like niche information about the topics. And then and then there's also a sign up page if you want to join one of our workshops. And so here we have like a calendar, and we plan on holding a workshop next week on the 24th. And to sign up, you just click this link, and then it will take you to a Google form, which you can fill out. And then here's our flyer for that workshop.
So anybody interested in signing up for the climate workshop, all you have to do is get your phone if you have an iPhone, and then you can like hold on it, and then it'll show you the QR. Ignore that. There we go. So then you can sign up on your phone. If anybody needs that, we'll keep it up. But we're ready to take questions now.
I've seen a hand in the crowd.
I have a question. So I was just curious, like everyone has inherent biases. So how did you work to keep like the people writing to keep the inherent biases of the people writing out of the articles? Like how did you work around that?
So the primary way that we like combated the bias was just by having the content team present both sides of the argument and also like read about like many different articles in order to get a better like understanding of the topic. And then again, they just, like they present both sides of the argument and like don't show bias.
Okay, and another question is like, are you gonna keep updating the website after the workshop is over?
Yeah, we plan on like updating the website with like possible like workshops that we're planning to hold, and also just like overall like just the website itself.
Cool. And another hand for himself.
So how do you determine if an article is unbiased or not? Like, how do you go about it in, like, do you just kind of look at the article and see if there is bias, or do you look at, basically, do you look for the lack of bias to determine if the article is biased, or how do you determine that?
So what we do is that what you're saying is an idea we had before, like determining if an article was biased or not, but that's not what we're going for. Rather, we're trying to write articles themselves that aren't biased. And the way we do that is, as Danook said, we provide both sides of the article. I mean, the argument, and we just like let the readers decide, right? But we don't actually determine bias in an article itself, because that's almost like practically impossible, as I think Japnor was saying. So obviously we're not creating an algorithm to identify if an article is biased. Rather, what we're doing is we're researching, we're finding the arguments on both sides of an just like a debate, and presenting them, rather than providing any sort of conclusion to an answer.
Okay, so how is this different from, because I know a website that does that. So I know there are websites that already do this, where they pull they take one issue and they pull articles from both sides of the spectrum, and they also get a neutral perspective on it. So how is what you guys are doing different than that?
Yeah, two answers. One, this is high school based. We are making this, which incentivizes other high schoolers to read it. Sure, your website may be like splitting up two sides, but are people reading it? Probably not. I don't know a single person that like looks up an article and like says, hey, like look at both of these, a world which is polarized, partisan, right? As high schoolers, what we do with our website is we incentivize other high schoolers to read it, because obviously, like as a high schooler, I want to read what other people are thinking, what other people are doing. That's why I go on like our website, our journalism website for our school, our newspaper, and I say, hey, what's going on here? I want to read some of this. I want to see what my fellow peers are doing. Similarly, what our website does is it's built by high schoolers. It's going to incentivize other high schoolers to read it. In addition, we're providing pros and cons from our from, I guess, yeah, that's the answer then.
Okay, so it's just targeted at a different audience, basically.
Yeah.
Okay, that makes a lot of sense. All right, thank you.
Mm-hmm.
And I've seen a new hand from Vikram.
Yeah, my question was like, if you're trying to like expand this, are you going to like recruit more people to like write these articles or make it like open source, or like what's kind of the future for the project?
That's a good idea. One is definitely we're gonna continue with our workshops, because I think the workshops are like good regardless. They have like innate like benefits with like students just discussing, learning more. In addition, we could potentially like recruit yes, we can probably have more people like maintain the website. Right now it's just like Danook and I. Maybe we can get writers to help us maintain the website, like flesh it out a bit. But yeah, we haven't thought that. The only thing we are really focusing right now are these workshops, because the workshops are probably like the most important at this point. Because I think of like high schoolers talking rather than just like reading articles. If we have interactive discussions, we're able to like kind of learn about like issues more.
Okay, thank you.
Yeah.
Very nice. Any other questions from the crowd? Cool. If not, I think we're
I think there is one question. There's still a raised hand.
I'm not sure if it's leftover hand or if it's new hand.
No,
Yeah.
never mind.
Yeah. But thank you for your reminder. And I think we've finished our first 3 workshops, and now we can take a 15 minutes break, and we will come back around 4, but somehow later than 4.
Okay. So we are the psychology in the community, and I'm one of the advisors, Emily Jordan, and our other advisor, Peter Sawyer, couldn't make it today, but I'm going to let our students take over from here.
So our project is the effect of memory bias on the recollection of the severity of the coronavirus pandemic. My name is Kaveri Gaduru, along with some of my other people.
I'm also working on this project. My name is Aya Fliachi.
Hello, my name is Yunshu, and I'm one of the other students working on this project.
My name is Emma, and I'm also one of the students working on this project.
I'm Moira, and I'm also working on this project.
So COVID-19 is a virus that has spread worldwide, creating a global pandemic. Since the pandemic has spanned over a year in the US, everyone's recollection of the events pertaining to the preceding months has most likely been influenced by the constant stream of varied information. So first, what is memory bias? So memory bias is a subjunctive bias that enhances or impairs one's recollection of information or of events. So the 2 types of memory bias that we focused on in our project was suggestibility and the misattribution effect. So suggestibility is using leading questions to forge what becomes that person's truth. The misattribution effect is the distortion of a memory, so one remembers a false memory or alters certain details of a real memory. People are constantly exposed to slightly varying information regarding the COVID-19 pandemic via social media, from peers, and mainstream news outlets. This exposure could potentially create memory bias and change people's perceptions of the pandemic and its severity, which could lead to further misinformation regarding the pandemic to spread, which leads us to our research question and hypothesis.
So our research question was, how can memory bias impact students' recollection of the severity of the COVID-19 pandemic? And then our hypothesis for different parts of our research. As for differences in learning environments, we predicted that students who mostly participated in in-person learning would likely have a slightly more positive outlook, whereas students who were mostly participating in remote learning would have a more negative outlook. For suggestibility, we predicted that the group given the optimistic survey would feel a little more inclined to reflect on the pandemic more favorably, which we acknowledged might just be a slight increase. And then we also predicted that the group given the more pessimistic survey would then feel more inclined to recall it less favorably. For the misattribution effect, we predict that the survey takers will lean towards the same view as the articles provided in the survey, and that we speculate after viewing the article titles, the survey takers will create connections to previous experiences, even though the reality may have been different.
So for our synthesis, just to reiterate what we said earlier for our research question, we intended to research how easily people's recollection of the severity of the COVID-19 pandemic was manipulated through memory bias. So in the past, more general studies have been performed to test the effects of memory bias, such as American psychologist Elizabeth Loftus's experiments on suggestibility, which found that after viewing video footage of the car crash, students given questions that were more aggressively worded usually remembered the 2 cars in the crash to be going at a significantly faster pace. The misattribution effect has also been demonstrated in many instances, especially prevalent among experiments dealing with eyewitness testimonies. Our study focuses more directly on the effect of these 2 types of cognitive biases in connection with the COVID-19 pandemic, with the population of our studies being teenage high school students. The context of our study was expanded to illustrate how the wording of the information we consume in the world around us and on the internet, and just through media in general, can affect us over prolonged periods of time, with this occurring without people even perceiving any of the changes that have occurred in our most vivid memories.
To test both the effects of suggestibility and misattribution together, our team utilized a survey. We made two different surveys, one that had a more pessimistic view of the events occurring during the pandemic, as well as the outcome of the pandemic, coupled with one that had a more optimistic view. We sent these surveys out to teachers at our respective schools, and we asked them to randomly assign these surveys to students via last names. To first test suggestibility, we created 7 questions which asked students to rate a series of statements on a scale of 1 to 5. Example questions that were paired were: how devastated was your local community by the pandemic on the first survey, and how much did the coronavirus affect your local community, which would be on the second survey. And then to test misattribution, we asked students to first read a series of statements that included articled headlines that were either optimistic or pessimistic, and then we asked them to generate some of their own responses to following questions. Examples of some headlines are: vaccines can get us to herd immunity despite the variants, which was more optimistic, or 5 reasons why COVID herd immunity is probably impossible, which would be on our pessimistic survey. And then a following question would be something like: how many people in the United States would you guess contracted the virus within the first year of the virus hitting the country? And then we wanted to see if students who read the more pessimistic article headlines would generate a higher number of cases. So I don't think Aya's here, so I think I can do the slide. To account for the differences in students' learning environments, we asked students what type of learning environment they have been in for the majority of the year, and this included being fully remote, fully in person, or hybrid, remote and in person. And then sorry.
No, sorry, I'm here. So for the data analysis, we had statistical tests that were performed using RStudio software. A 2-sample t-test was used to see if there was a significant difference between the 2 groups tested. Normality was assumed due to our relatively large sample size, and equality of variance between each group was determined by creating box plots of the data. A 3-sample ANOVA test was used to see if there was a significant correlation between responses and what type of learning environment participants have been in for the majority of the school year.
Okay, so for the results of our learning environment comparison, the ANOVA test for all of our questions resulted in an F value greater than 0.05. So there were no statistically significant differences between groups on an alpha level of 0.05 that we could account for. Right here is a box plot of question 3, which was the one that had the closest F value to 0.05, but even then, that value was 0.36. And question 3 was just about, on a scale of 1 to 5, around what proportion of your school and community's events or activities were changed as the result of the pandemic. Even though you can see a little bit of a pattern forming in the graph where people who were fully in person and hybrid remote had less severe responses than people in fully remote, there's still no significant pattern that we can draw from that.
For our 7 suggestibility questions, we found 3 to be statistically significant at an alpha level equaling 0.05. The first question of that was: how devastated was your local community versus how much was your local community affected, which generated a p-value shown here, as well as this box plot. Our second question that was statistically significant was how much do you think mental health declined versus how much do you think mental health improved, which generated this p-value and this box plot. And our final question that was statistically significant was how much has quarantine increased feelings of loneliness as opposed to how much has quarantine impacted feelings of loneliness, which generated this p-value and then this box plot. We found that the questions that were statistically significant utilized verbs that had the most drastic and direct differences, and they connoted more implications as opposed to other questions that did not use differences in wording that was as aggressive. And we found that there was a spectrum of how much suggestibility, especially wording bias, affected the reader, which mainly depended on the degree of comparability between the two questions / words utilized. So you can see here listed from least to most effective. Something like canceled versus changed, which is quite similar in wording, was not as effective as something compared to devastated versus simply affected.
So out of our 10 misattribution questions, we found one to be statistically significant at an alpha level equal to 0.05. And this question was, in how many more months would you guess that things will be functioning like normal? The p-value is shown. And so we found that the group that had received the survey with positive news headlines had on average answered that it would take more months before things would go back to normal compared to the group with negative headlines. So this would be a type 2 error because we failed to reject our null hypothesis. We previously thought that the group that had received the survey with positive news headlines would answer that it would take less months before things go back to normal. So our result could have turned out this way because of experimental errors such as not having enough data or unaccounted interaction between other variables. Our sample sizes could also have been unbalanced, thus altering the results. These are also two more examples of some box plots that of our data from two other questions, but these did not have a p-value of less than 0.05, so we couldn't use them, but you can see that there is still a difference in the group's responses.
So for our implications, this research will allow us to understand how our cognitive bias either enriched or reduced our memory of this past year regarding the pandemic. The information can influence our objective reasoning of how individuals are perceiving and experiencing the ongoing virus. It can also benefit those who are caught up in the myths and misunderstandings by clarifying how memory bias could have disoriented our perceptions. Those who are responsible for educating the public on the global pandemic, such as healthcare professionals, the media, etc., can utilize this research to communicate these facts in more conducive manners.
Okay, those are our references, and that was our presentation. Does anyone have any questions?
So just to make sure, so strong rhetorical choices basically could control how everyone or how the reader interpreted the subject matter, right? Basically, if you wrote using very fiery language, you're more likely to get a reaction out of them.
Yeah, we found that if you compared people who got questions that were worded less aggressively as opposed to questions that were worded more aggressively, people usually had a bigger difference in reaction.
Okay, thank you.
And Will, I see your hand.
Yeah, I think your findings are really cool, and I would actually encourage you to look into some kind of publication method for the results that you've found, because you have actually you've done a proper survey, you have randomized your sample, you've done the statistics necessary. So you could probably write it up. I would recommend something called the Journal of Emerging Investigators. I'm going to paste a link in the chat in just a second. If one or more of you are interested in actually going ahead and doing this, I might be in a good contact, or maybe one of your advisors has experience with publishing. But just something to think about if you want to get go like the next step beyond what you've done here.
Yep, and definitely if you can think about some venues to submit this work, posters or poster sessions, student paper, they can all work. And but definitely you will need to furnish it into a full APA style paper. But I can see the potential since this is an interesting result. And Nila?
Great, yeah, great presentation, guys. It was really well thought out research. I was actually interested in some of the statistical choices that you guys made. Like, for example, how did you guys decide to use a 0.05 alpha value? Since I saw that you guys consistently used it for all of your results in evaluating whether your results were significant or not.
Well, I think alpha equals 0.05 is just one of the most widely used alpha levels. So we wanted to stay consistent with that, with our own research.
And I think in probably one of your slide, you said F statistic instead of p-value. So you probably want to fix that. Somewhere you said like F is larger than 0.05 so that you fail to reject, but that should be p-value.
That's because that test was an ANOVA test, a three sample ANOVA test rather than a t-test.
Okay.
So it doesn't have a p-value.
Then that makes sense. Then probably like specify and clarify it. And if I want to make some like further suggestions, probably think about like how would you make your graphs better by making the groups A or B more explicit, and also the questions using the question title, like make the axis and labeling and captions. You will need to fix that if you want to submit it as a paper. And also for slide 17, I guess you've mentioned that there's a type 2 error, but I am a little bit confused about that since it seems like you have a low p-value, so you reject the null hypothesis. But type 2 error is when you fail to reject the false null hypothesis. So would you like to elaborate more on that?
Oh, whenever I researched the different types of errors, I must have like went on a wrong website or something, but I thought whenever you failed to reject the null hypothesis, it was a type 2 error. So that's what I thought our data showed.
So a p-value less than 0.05 is like a significant p-value, if I'm not mistaken. And then you will successfully reject your null hypothesis in that sense. But I'm not sure if you have formulated your question in a different way. And if so, probably you will need to make that more explicit and just for things to consider in your future work. Okay, any other questions from the audience? Not, we can move on to our next group, the Interstellar team.
Hey, hi, I'm Anoop, and I think Pratham is going to start us off and introduce everyone.
So, well, hello, everybody. We are the Interstellar Exploration Group. I'm here today with Julian, Kalyan. Jacob couldn't make it today, but Lily and Renuk are also here. And of course, shout out to our awesome advisors, Michael and Anoop.
So for our research, or for our project, our research question was, how can we design a probe that can find the best path between various star systems and collect meaningful data about each system it visits? For this project, we had to take some initial learning steps. This includes learning about algorithms and graphs, as well as astronomy and NASA's space missions. Our final plan will be to write code and design a probe to travel to and gather data on various star systems.
So to represent our research question, we are using what are known as graphs, and it's basically a data structure that is used to model relationships between objects. A graph has nodes and edges. So the nodes, as you can see, are the little circles and the edges are the lines. It can be used to represent a network or basically anything that's connected in some way. And a really simple way to think about this is the nodes are like houses and the edges are like streets. Some streets can connect you to any house that you want to, but sometimes there's streets that are dead ends. So that's kind of a good way to think about it. So applications of graphs to interstellar exploration, we can use a graph to represent the network of all the different star systems that we want to travel to. So in this case, each star would be a node and each edge would be a path between the two star systems. And this picture on the screen isn't the exact system of stars that we used because some of ours are a little closer together. So it might have been a little hard to kind of capture that in a 2D setting, but this 2D picture is a really nice visual representation of how we could use star systems and put them into a graph.
So graphs become much more useful whenever edges are given special characteristics. So one special characteristic of edges is shown on the left in the slide here, and it's edge weight, which is generally some value that represents, it can represent anything, but I think a lot of times it's thought of kind of as like the distance between nodes. And that's how we'll actually be using it in our presentation. So essentially, if all of the nodes represent different star systems, then we can use the edge weight as a way to actually tell the distance between these two star systems. Another characteristic is direction, which essentially defines which way you can traverse an edge. So if you can go from one node to the other, from the other node to the other node, or both directions. But this isn't super important for our graph just because we can travel in any direction we want. Something else to consider is graph completeness. This is like a special type of graph where each pair of nodes is actually connected by an edge, which would mean that you can kind of go in any path you want to, essentially, and there are no restrictions. So this is important for our system, as we can go any way we want, because we didn't really consider any sort of obstacles that would like block any sort of, I guess, path between two star systems. And this will actually come in pretty handy later whenever we talk about different algorithms to kind of traverse a graph.
Right, so one of the algorithms, I guess, that you can use to traverse the graph, and one that we focused on as like using a variation for our code, is called breadth first search. So breadth first search is an algorithm used to traverse graphs. Another common one is depth first search, but it doesn't really apply for at least what we wanted to do. So breadth first search, basically the way it works is, and as shown in the image, I guess, it first explores all of the neighboring nodes to the current depth node before moving on to the next like set of nodes, I guess. So if you start at this like root here, 1, basically what it's going to do is it's going to travel first to 2, then 3, then 4, before going to the next level of depth. So like where 5, 6, 7, and 8 are. And from there, basically, it calculates like as Julian was explaining, with the different weights that the edges provide, it calculates the shortest path and the best way to travel. The time complexity of this algorithm can be represented as O n plus E, where n is every node and E is every edge, because this is basically the worst case scenario where every node and edge will have to be explored.
Yeah, so this right here is just like a little visualization of our algorithm running. So I think that's like a 3D plot in Matplotlib. And it essentially just shows you kind of how our algorithm actually branches out and tries all of these different combinations. We actually only used it, or we only have the video for the first 4 just because there's so many different combinations that would take like forever to actually show them all. But it kind of gives a nice visualization of how it actually branches around and tries to find the shortest path. And then here's the final solution I found.
So when designing our probe, our objective was to design a probe that can accomplish the tasks in our code. And our first step to completing this objective is our assumptions.
assumptions are that stars and obstacles move at a negligible rate. The probe can overcome gravity as needed. Has enough fuel to get where it needs to go. We have a fast spacecraft and we ignore relativistic effects. We designed our probe to collect data on composition, gravitational strength, temperature, electrical and magnetic fields, luminosity, solar winds, trends in composition, and images of star systems. To design a probe, we also researched stars to see what stars have special properties that would be interesting to study. And we also looked at NASA's space probe missions to see what instruments they use and what they use those instruments to study. And we combined our findings into a final probe. As I was saying earlier, we looked at stars. Here's the full list of all the star systems that we included in code. Pictured at the top left is the Van Mayen 2 star system. We selected this star system because of its composition and because it's a polluted white dwarf. At the bottom left is the Alpha Centauri system, and this star system is the closest star system at 4.37 light years, and it has two main stars, one of which could have planets to support life. At the bottom right is Wolf 359. It's a red dwarf, but unlike other red dwarfs that are hostile, it is cool enough to house compounds like water and titanium 2 oxide. And Vega at the top right is a star system with an electrical field and regional temperature differences due to high rotational speed, causing it to bulge out at the equator. Here's the list of the NASA space probe missions that we looked into. First, at the top is Pioneer 11. The mission of Pioneer 11 was the first mission to explore Saturn and its main rings, and it was the second mission to explore Jupiter and the outer solar system. On the left is the Voyager 1 probe. It explored Jovian and Saturnian systems as well as new moons and active volcanoes. Voyager 1 found 5 new moons and the G ring. It was also the first man-made object to leave the solar system. And Messenger at the bottom is a probe sent to Mercury to learn about the small planet, including its geology, atmospheric characteristics, composition, and magnetic field.
All right, so I just wanted to add, or can we go back? Yeah, I just wanted to add on to that. So Pioneer 11 is pictured at the top there. Voyager 1 is on the left. Then we have Messenger on the bottom. And then New Horizons, that was a 2006 mission sent by NASA, showed on the right. And so the goal of that was to find out more about Pluto specifically and measure its composition, get some new images of the dwarf planet. And after that, in about 4 years, so that's 2025, it's expected to reach the Kuiper Belt, which is ultimately like almost like a barrier outside the solar system, which is composed of asteroids and ice. And so by sending it out there, we'll be able to get more info about exactly what's in the Kuiper Belt. And then finally, there's the Parker Solar Probe, which is pictured directly in the center there. So the Parker Solar Probe is actually a current NASA mission, and it's much like the name indicates, it's headed towards the sun. And so it actually had two main goals. The first was to fly by Venus and understand why its atmosphere kind of tapers behind it like a tail due to solar winds. And it did that on February 20th of this year. So we have some new pictures of Venus if you look up the Parker Solar Probe. But also specifically with the sun, what it's going to do is by 2025, it's going to do a close flyby. And by close, I mean 4 million miles from the surface of the sun. And it's going to take measurements on different particles in solar flares and understanding kind of why the corona, which is a layer above the surface of the sun, why it's so hot and how solar flares originate from that layer. And so then our next step was to take all of those NASA missions research, kind of think about what kind of data we wanted to gather from the stars, and then use instruments from those pre-existing probes and adapt them and use them in our final design. So for example, here you see 6 different instruments, specifically sensors, that we would use in our probe. It includes all of the Parker Solar Probe instruments, except for GRNS, EPPS. Both of those are from Messenger, which was the probe sent to Mercury. And so the purpose of WHISPER was it's ultimately a camera, and it serves to image the sun on the Parker Solar Probe, and it's pictured at the top left there. Then the GRNS is the gamma ray and neutron spectrometer, And that's pictured on the top right there. And that serves to measure the intensity of gamma rays and also the presence of neutrons in radiation. The EPPS measures energetic particles in plasma, which is very helpful considering that the sun and stars in general are primarily made of plasma. Then SWEEP, and also the EPPS is shown in that section of 4 at the top. It's the bottom left. Then SWEEP is the bottom right of the block of 4 pictures. And what that does is it measures the velocity of different particles in solar flares to understand kind of why they have so much energy. Where did the energy come from in solar flares? And then ISIS, which is shown at the bottom there, that serves to measure finer particles that SWEEP can't pick up, but also it creates an emission spectrum, or sorry, an absorption spectrum to understand the composition of the stars based on the light. And we also included some structural components which would have to be in the probe, such as a heat shield, of course, then an antenna to transmit data, the main body that would hold everything, our power source, solid state memory, which is ultimately a memory that doesn't have a disk like random access memory, and it's better at resisting electromagnetic radiation. And then finally, occulters, which is just a general term for flaps that can block out excess sunlight that may blur images or ruin measurements. And then finally, we took all of that and put it into a visual representation of what our proposed probe might look like. So you can see the heat shield on the left there, that big white round square type shape. And behind it are all of the components. We have 2 solar panels, which are extended on either side of the robot for supplementary power given, since we're near a star, might as well use its energy. Then we have all of the components behind it based on what it's measuring. So we have Whisper, which needs to be more closer to the front of the robot to get better images. We have ISIS, which could then have better access to the finer particles and make a more accurate spectrum. We have SWEEP, which is kind of sticking off of the probe almost. And what that does is it gives it better access to those particles that it can measure the velocity of. Then we have EPPS and GRNS in a place such that whenever a solar flare passes the probe, they would be able to pick up those high energy particles or other electromagnetic radiation. And then finally, we have fields. So fields actually measure, it's a system of 4 antennas. And so what it measures is electrical fields and magnetic fields, hence the name. And it would just trail behind the probe to get a better feel for the electrical field around the star. Right, so for future goals of the probe specifically, what we would want to do is kind of take it further, look into more advanced and complex parts that we could use, maybe look into composition. Like, for example, what could we make the heat shield out of to make it safer for the components? Is there something we could do to the sensors that would make them better at resisting radiation? Then, of course, we want to remove some of those rather absurd assumptions we had to make for the project, such as light speed. Now, naturally, light speed technology doesn't exist, but maybe we could look into better propulsion systems that are currently theoretical, but might provide a better travel between star systems, better communication, because once you get a couple light years out of the solar system, a high gain antenna really isn't going to do much. So we could probably look into more of that, and also trying to make it more realistic in that introducing obstacles, can we modify the design to combat like maneuvering around, say, asteroids or traveling through a gravitational field? And then Kalyan can go into some of the future goals for our code.
Yeah, so specifically for coding, some of our future goals are, although breadth first search is a complete algorithm, meaning that it will always produce the best solution, it's going to get much slower the more star systems we add in. So it's not really viable whenever we account for like the massive amount of star systems we actually want to travel to and figure out where to go. So although it's like very fast with a small amount of star system, if we added more, it's going to get like exponentially slower. So a good idea maybe that we could consider for the future is using an approximate algorithm, which will not be, I guess, like complete. So it won't always produce the best solution, but it will produce a good enough solution, which would be much more effective for larger data sets.
Awesome. Yeah. Thank you for listening, and we'll take any questions that you might have.
Very cool. Any questions from the audience? Sup, I see your hand.
I might have just missed this, but what language did you guys use?
We used Python.
Python.
How did how did you guys represent the graph in the code, or the tree rather? I guess, like, how did you, like, what data structure did you guys use to represent that and to like actually do the search on?
I can take this. Actually, I wasn't there like the day whenever we coded most of it, so I don't especially know. Lily, do you either know? I mean, we either used like an adjacency list or adjacency matrix. We didn't go over these just because it would take up some time, but there are generally like two different ways to store a graph. You can either store a graph as like a big matrix where you can think of it as column I, row J represents like maybe like whether or not there's a edge between node I and node J. And if you have a weighted graph, then that like entry in the matrix could represent like the distance, right? Lily or Kalyan, do either of you guys know like which data structure, how we actually represented the graph in Python?
Because it sounds very similar to a linked list, but I'm not sure if that's exactly what you guys used or not.
No, Julian, you were 100% right when you said an adjacency matrix. We kind of played around with a couple different ideas. When we originally implemented BFS, we just used a simple like two, like X and Y kind of like 2D plot. And then for the presentation, we wanted to make something that was more realistic with 3D. So we used some of the adjacency matrices. But originally, I think we just had things in like kind of like a list format or an array almost. It was pretty simple at first, but then we built it up.
All right, thank you.
Any other question? Well,
I'm just curious, does technology exist for like extrasolar communication? You were talking about like and beyond a high gain antenna. I've never heard of what technology we would actually use for that.
Yeah, so that's an interesting question because I mean, we don't really have data on extrasolar communication, you know? Like, I mean, we've only sent so many things out of the solar system like Voyager 1 and soon New Horizons. So, I mean, those two probes specifically are sending data. So, I mean, at least like in the area just outside the solar system, yes, we do have the technology to communicate, though I can't really tell you about like other star systems.
yep, and I definitely like your the visualization, and it's a good take to move it to the 3D realm. Any other questions? Cool. If not, we can move on to our next team, which is the video game trailer.
I'm gonna share my screen quickly.
Cool.
Okay. All right, and then Ariel, you can kick things off.
All right, so hi everyone. My name is Arun Surfney, and I'm part of this group. If everyone else in the group wants to introduce themselves.
Hi, I'm John Beeson.
I'm Ben Mikis.
Oh, hello, my name's Maria.
Hello, I'm Olga.
Hi, my name is Yvonne.
All right, and our project was we created a video game trailer for the video game that we designed called Passing.
We are a group of artists, animators, and musicians working together to create a video game trailer, which we need artists, animators, musicians, and an editor. So many of us had to do multiple different parts of our project. Also, special thanks to our project advisors, Jonathan Wong, Caleb Koo, and Caleb Lil.
So what is our project? Our project was to create a video game trailer. Our project combines use of animation, sound design, and story development. So a trailer is essential to like the success of any video game, just in marketing, getting the word out there before you publish your game. So on top of all that, we tried making our trailer gripping and interesting.
So our goal was to make a successful trailer that was captivating to the audience. So we were trying to achieve how we told our story and hook in as many people as possible. We included many different elements to actually make this trailer, such as writing, designing, and creating a presentation that was also captivating. We also determined how our actual game would work moving forward and created a story that would be more intriguing and interesting.
For brainstorming and decision making, we had a group decision making process in which we only added to each other and recognized that there were no bad ideas. On the first couple of days, we threw all of our ideas together and tried to come up with something that could stay true to all of them at the same time. Our original idea had been this adventure, psychological horror, platforming game that basically fit into every category, and as we went along, we narrowed it down. We also divided tasks into for different groups so that we could make small decisions without having to have the whole large group involved. This made our decision making far more efficient.
So one of the major setbacks that we experienced was time. A fully fledged video game trailer contains many components that range from brainstorming to editing, which can take a while to implement. Another setback that we experienced was trying to figure out a program called Unity, which took too long and resulted in us not being able to incorporate any actual gameplay within the trailer. COVID-19 also caused its fair share of complications, which I'm sure you were all familiar with.
So our project had a lot of the art aspect, at least, had a lot of very wild colors that we used to try to entice people and make our trailer more eye-catching. We used various different colors like bright purples, light blues, pink, stuff that would attract people's eyes and force them to look at it. And the animation we did on Toon Boom Harmony, was a software that our advisor found that actually made it really simple and easy and quick and effective for us to be able to come up with this trailer and make it look as good as it is. So these are just some of the art pieces that were used in our trailer, and as you can see these vibrant colors that attract the eyes, so that we can attract more viewers and stuff like that.
And here we have more of our concept art, some of which for these next two slides did not get into the trailer because either we didn't have enough time to put it in or it did not fit the final theme of the trailer.
And here is even more of our concept art, here featuring some character designs. When we were creating character designs, we first wanted to create the main character to make them as bland and easy to insert yourself into the role of the main character. And then when we designed the friend character, we wanted to make them purposefully like happy and bubbly and contrast the main character as much as possible. So here you can see some of the character designs that we did.
So the story of our game, well, the story of what it would be, is about the main character who goes on a journey while recovering from the death of his friend who committed suicide. Our character goes on a journey through a different world as he deals with the grief and regret that he feels.
Some of the general themes that is in our video game trailer include regret that the main character feels for not being able to do anything about his friend's death. Ultimately, he goes on a journey to his own mind as a way to escape the harsh reality that he is dealing with and figures out how to forgive himself.
Yeah, and now we will show our finished trailer. Slight warning, there are some flashing images, so if you have epilepsy, that's a slight warning.
All right. So I think our trailer worked pretty well, and I think it accomplished the task that it was supposed to do. Obviously, due to time restraints and stuff like that, there were some minor details that could have been changed, that should have been changed, but due to some of the stuff that we talked about earlier, we couldn't. But I think it accomplished its task that it was supposed to do, and that it was very eye-catching with these bright colors, like I talked about before, to engage and invite more people to see it. And the similarity to the original plan, it was pretty similar to the ideas we had before. Obviously, again, like I said before, some minor details had to be cut due to time restraints. But we were still able to introduce the character and the basic storyline, which again was just the main objective.
Oops. So a big part of our project, obviously, was putting together the entire video. So I just briefly talk about the editing. All of the editing for the video was done in Shotcut, which is a free editing software for PC. So here on the picture, you can see what that looks like on my end when I was editing the video. And now I'm just going to quickly explain the editing process. The first thing that we did was we just gathered all the media we had, and I just slapped it in there. And then I looked through everything we had and matched up all the visually similar elements and the things that we knew we wanted to include. After that, I collaborated with the music team to settle on a soundtrack for the video. This took kind of a long time. There were so many different audio clips and things, so we had to sit through there and listen to them and see which ones sounded well. We played around with tons of different sounds, and then we settled on this looping, like calm motif, which you could hear in the video game trailer. And then after that is just the bulk of the editing. This is mainly just matching video and audio and adding effects as needed. And then after this was all done, I added finishing touches. So like a reversed version of the motif to build suspense, changes to the pacing, and of course, some credits at the end. Throughout this whole process, I referred back to the team extensively, and together we created the entire video.
So for music, we went for two styles. So we went for more of a chill, ambient kind of style that was used throughout the trailer. It was used mostly through the trailer and gave a sense of uncertainty due to the ambience. And mainly we can see this being used through these examples. We have one that didn't make it, but yeah. Yeah, so moving on to more of the eerie-ish, creepy music that was used around the end of the video. It brought out more of a logical horror aspect to the game, which we wanted to keep unknown in the trailer until they would quote unquote start playing the game. And this was more of a concept moving forward, as I said, as this would be used mainly in the game. And I have a couple of examples. And we have one more. We also had some other pieces that didn't make it, but was more of a concept for moving forward.
What would the next step to this project be? The trailer would actually include gameplay, and ideally, a game would exist with multiple platforms and environments, multiple characters that would consist of the friend group that you saw within the trailer, and several endings that could be achieved depending on which dialogue options were chosen throughout the game. Puzzles and boss fights would also be included, as well as improved 3D graphics with more details. Last but not least, it would convey a message for the audience to think about. Thank you for listening.
Yay, this is so cool.
That
I,
ending was so sick. That was
yeah.
so cool with the reversing and the him grabbing. That was so good. Really wish I was playing that game now. I would have bought that game after that trailer.
I like all aspect of it, and especially the design and the ending, as Sub commented. Any questions or other comments from the
Did you
crowd?
guys draw the art? Like, did you guys? That was cool. That was really good art.
Yeah, thank you. We did all of the art. Yeah.
That's even the concept art is much better than anything that I could do. The stuff that you guys threw out is like 10 times better than what I could do.
Well, yeah, that's the value of bringing people from different backgrounds together to do one thing. And yeah, glad to see some cool result. Any other questions? Cool. If not, we can move on to our last team, aim of the game. I never know how do you pronounce the first word. Is it aim?
Yeah, we just call it aim of the game.
Sure.
All right, so hello everyone, we're the last team, aim of the game. I guess you can guess it's basically about game AI. The two instructors are me and the other Brandon, and we have about 7 active members, and I'll let the students take control of the rest.
All right, so what this workshop is basically about is technology that we've all heard about in the news before is AI, right? We're seeing the incredible things that this AI is doing, but not very many people know what it is or even how it works. So this workshop was designed to increase our knowledge about that so that when we hear about these things, we'll have a better idea of what it is that's actually affecting our lives. You know, it's not all just Terminator and Skynet. AI does actually help people, so it's good to know how that works. For this particular workshop, we looked at AI through games because it's a everyone likes games, and it's a fun way to see the power of AI while still not getting bored out of your mind with math and graphs and comp sci. So for the final product, we picked the checkers game to create an AI for, which we'll demonstrate at the end of the presentation. We picked checkers because it was an easy game to create an AI for, but not so easy to the point where we didn't even need an AI. It was complex enough to present a challenge, but not so complicated like chess, where we weren't able to get it done. To build up to the checkers games, we first had to build our base knowledge. So we learned about first what the different types of games are, how it is they're classified, what certain requirements are for certain games. And we also looked at different strategies for how you can play certain types of game optimally. Basically, how does the strategy change depending on the factors? What's the correlation there? And then how can we take that and put it onto a computer? If you look in the bottom picture, I really want to convey the power that AI has and the fact that, it will take over the world someday. And that is a very good start for the power of AI.
So getting into the problem that we have to solve, like I was saying, our goal is to use AI and algorithm functions to play and solve games. And the project that we used was checkers. And checkers overall is a universally played game with players on every single continent. So it's a pretty common game. I would say like almost every family probably has it in their home. And so we decided to use that as a project and try to figure out a function and algorithm and AI that like solves it and plays with players. So choosing the actual game, yeah, so it's like super popular because almost every family has it. And on top of that, especially during COVID, there's a lot of like family time. Lots of people are inside. It's really easy to just grab a board game and play. And overall, it's really important to like use AI, especially in terms of games, because just overall AI, it helps humans right now, and it's going to be a major part of the future because it's everything is rapidly digitizing right now. And on top of that, AI in gaming specifically is overall improving the gaming experience, making it easier and more immersive and interesting for players right now. And it's being like constantly trained, and so it'll always learn and get better, making sure that the player and the AI overall improves. And that's why the whole gaming experience becomes better for anyone who's going to use our game.
Our team members were myself, Philip, Rashil, Savam, Varun, Victor, Vikram, Vishal. Our advisors were Brandon, the two Brandons. And then to make this project, we broke the process into 4 groups. Researching AI, coding AI, researching game, and coding game. And so the game here is just like all the game logic and the UI and all the structure around it. Each team member contributed to at least one group, and then the advisors helped with teaching about the game AIs and contributing to all the groups. We collaborated via GitHub, Code Sandbox, which you can think of as sort of a Google Docs, but for web programming, and then regular Zoom meetings, which were 3 hours every Sunday.
Yeah, so to create this AI, there's like a huge process that goes into it. So first off, as Vikram explained, we did this on Code Sandbox, which uses JavaScript and HTML, which we can write with it and collaborate on together. So the first step is to create the UI layout and create the entire checkers board, and along with all of the other game mechanics, including jumping, moving around pieces, being able to see the valid moves. In the image at the top right hand of the corner, that's basically when you click on a piece, it shows you which moves you can move to. It also needs to be able to detect promotions and capturing pieces. One of the main challenges of this was multi-jumps. So one of the rules in checkers is that after you capture a piece and you can capture another one after, you have the potential to do a multi-jump, which is capturing 2 pieces or more at once. We try to do a ton of like recursion projections and project like all the multi-jump possibilities. But there's a lot of issues with that, including it was difficult to write code that would project the second layer of multi-jumps and capturing, etc. But we're able to solve this all with a turn system. that would essentially kind of force you to take the multi-jump in the next turn. And so then after this UI is done, we create the computer AI component of it. So the first part of the computer AI is to be able to get the AI to control the player. So that means we create a ton of functions and custom tools so the AI is able to move around the opponents depending on red or black or which one it wants. So first off, we have to give it a ton of custom game analysis tools, including evaluation functions, which is the snippet of code on this screen. And then other functions such as its own update board, so that it can use all of this data to be able to create its own projection and to create its own, to determine the best possible move. And so the recursion algorithm, or the AI algorithm we use, is the minimax algorithm, which is using depth first search recursion that allows it to see a tree of all of the different possible outcomes, and it navigates the tree to determine which move is the best one. And then some of the optimizations we used are alpha beta pruning, which can see the, for each node, it can see the layer above it, and it determines this and whether or not it should continue with this node. There's a ton of challenges with creating this algorithm in AI, including projecting multi-jumps. The AI had a lot of trouble with trying to figure out like if it can jump multiple times, and that required a lot of integration and creating a lot of casework in order to make it be able to account for these multi-jumps. And then finally, we also had creating end states, and the end states where it's like win or loses 3 errors before, but with a lot of tuning up, we were able to fix that. And then also version coordination was rather difficult because sometimes adding or subtracting versions made it like erase some of our previous work that we've done. And that was a bit hard to work around. And so in the end, we had an AI that could see 6 moves ahead, and we'll demo it at the end of this.
So our minimum viable product, what we initially wanted to create was just a basic checkers game that had the normal functionalities of a checkers game. And with that as well, it's like an AI that could win most of the time and could predict like just a few like have like a small depth and just predict a few moves down the line. So we ended up kind of surpassing that. So we have a checkers AI that is like nearly unbeatable. It's almost unbeatable, and it has a depth of 6. So we initially had like an earlier depth of 5, but we realized that our minimax algorithm would still like be quick enough to win a game with a depth of 6. So the future improvements that we want to make are maybe some more optimizations to make the code more efficient and faster, and adjust the weights so that way the program can accurately decide whether it wants to optimize to create like kings or just like take regular pieces and things like that. We also want to make our AI a bit smarter because although it can work with like multi jumps, it's still not as good as we like to. It's still not as good as we want it to be. So we want to like optimize our AI for multi jumps and things like that, as well as allowing it to know like when to trade pieces in order to like create a stale and things like that. And then some improvements that we did within the workshops itself, where we added an evaluation function as part of our minimax algorithm. And like I already said, we already added a depth of 6. We improved that from 5.
Just really quick before we go into the demo, I think to add on to what Victor was saying 2 slides ago when he discussed the minimax and the depth first search, the minimax algorithm is basically just a way for the computer to generate every possible move that can be made from that particular board state. And then the depth first search basically just goes through that entire list of possibilities and picks what is the best possibility, what will result in you winning, which is in this case considered to be the best possibility, and you losing is the worst possibility. Just wanted to clarify that.
All right, as promised, we're gonna start demoing our checkers game.
All right, I'm gonna share my screen here. All right, so this is the code sandbox that we're working with. And so I'll just go through the code very briefly here. This is our index.js file, which basically creates the mechanics of the board and also the board layout. And so here are some game mechanics, some functions, and then also creating the actual UI and the drawings So basically drawing out the pieces, drawing out all of the possible moves that you can do, and handling all the turns and all the functions that you need. All right, and then we have our AI.js script, which is where the main AI component happens. And so here we have where it's called from the main turn manager, and then it calls all of the minimax algorithm processing, board evaluation functions, and other functions that we have here that are basically like custom evaluations. And so then here is the demo of the game. As you can see on the bottom, we can choose our color, and then the AI will play as the opposing player. I'm going to start off as red for this one. And then what it's doing is that right now, because it doesn't really see much matter in like in the other moves, because it's all the same value, it will move this one first because it's first in the list. And then you can continue to, it will trade pieces with you, and you can continue to play with it. And then see, I move here and it took me. And then it's able to double jump me right over here because I didn't watch out for that. So it is fairly good. It is beatable though. So I'll send the link for you guys to try out in a moment, but you can beat it. It is possible, yeah. Because the main thing is that right now its depth of 6 might not be enough. And also the value of a piece can't just be determined based on if it's a king or not. It can be also determined on its position on the board, what state the game is in right now, whether it's end game or start game. And so if we refine the evaluation function more, it will be a better AI, and it'll be able to do more things. And so at this rate, I pretty much lost. I have to move one here, it'll take me on the next move, and then this one can't move anywhere, and the AI won. And so I will send this in the chat now, and you guys can try it out for yourself.
It's ridiculously difficult to beat. I tried to play 15 games against it. I conceded on 10, and out of the 5 that I actually finished, I was only able to win 1 of them.
Yeah, same. I played like 30
It's
games.
hard.
Yeah.
And this is not even the best we could do. Like most, like good, like if we had more time with the project, we would have been able to take this up to a depth of 9 or 10. At which point it would have been virtually unbeatable. Like you would have needed a checkers grandmaster to beat our AI, which just again goes to show the power of AI. None of us in this project are good at checkers. Well, maybe we're good, but we're not masters by any stretch of the imagination. But we did understand how computers work and how much they love numbers. And so we utilized that to virtually become masters at checkers.
Yep.
All right, that about wraps up the presentation. If you guys aren't trying to beat the checkers AI, does anyone have any questions?
This is very cool. I see Jasmine, your hand.
Yeah, this is super cool. I'm just curious, like, is there a way you can make it easier, like, so that people might actually be able to win some?
If we turn down the depth, it should be a lot easier.
So what if we had to improve on this project, one of the improvements we could have done is we would have had like a mode selection where you could pick easy, big, medium, or hard. Easy turns down the depth to like it can only look a few moves ahead. Medium bumps it up to maybe 5 or 6 moves ahead, and advanced is 9 or 10 moves ahead. So that is something that can be done.
Cool, thanks.
Cool, and I actually have some questions. So when you're optimizing your hyperparameters, like the depth, well, I guess like for this game, it seems like the higher the better. But have you tried I don't know, like let the AI play against the AI in some sense?
Yeah, I tried it. It ended up like mirroring the other person's move for like the first 10 moves. And then it started taking each other. I think eventually red won. Yeah.
Okay, so is this the deterministic result because of how your algorithm work, or is it because of
Yeah, it's the same algorithm playing itself.
Okay.
At which point I think whoever moves first ends up winning.
Okay. Jonathan?
So congratulations on your project. Are you going to take it further with trying other games, or what are your other plans for it?
Yeah, personally, I want to be able to do reinforcement learning and deep learning and other aspects of AI. I don't know what the other people would like to do.
Yeah, next steps with this is we can stick with games and just implement better algorithms, because what we have done in this workshop is a very small subset of AI. We didn't even touch anything with machine learning and deep learning. So next step would involve just us either sticking with games or not sticking with games, and then learning about more advanced, more complicated algorithms that will require stuff like training data. And then I think the cookies group as well, the machine learning part, taking in that data, training a model, having it produce that output, doing all that pre-processing with the data, learning how to do all that stuff would be good next steps that we would all take.
I see. Thank you. Thank you.
No problem. Anyone else?
Yeah, I'm very glad that you have completed this project and written that much of a code. And congratulations. And yeah, it's super cool to see and able to play against the AI, just try out ourselves. And we should definitely put this up on a website so that any follow-up, the future Project Night members can also see your game.
That's the application requirement. If you want to join the AI group again, you have to beat the Checkers AI.
Oh yeah. This is a good screening.
Yeah.
Question next time. Cool. Jasmine, I'm not sure if it's a leftover hand. Okay. Cool. So if there's no any other question, thank you all for coming. And yeah, that's about, I guess, the end of the showcase.